this. We ran out of time. So I get 75 multiplied by e raised to power 10 and subtract 775. So the approximation is quite big. 1651209.94. And this was problem 46 in 4.4. 46. Okay, and then they were asking, they were asking us, so I'm just going to change this into page 1 and this into page 2, and I'm going to put the date here as 21. So I'm going to scan this again. Okay, so in part B, we're asked to find the average. And the average was still between 0 and 10. So remember, the average value is 1 over 10 minus 0, the integral from 0 to 10 from r prime minus c prime. I'm not going to write it again. R prime of t minus c prime of t. Of course, do not forget dt. Close the parenthesis, the pair parentheses, and dt. But we already have this. It's right here. I'm going to replace it. So then I have 1 divided by 10 multiplied by 1651209.94. All I have to do is move the decimal point one spot by dividing by 10. So this is 1651209.94. And that was, of course, in dollars. It was the average daily profit. Do you feel like practicing anything, or can we continue and finish chapter 4? Is there anything that you encountered in my lab math, in homework, in anything that you would like to start with, or we'll continue and finish up chapter 4?
This isn't really something I encountered, it's just kind of something I'm curious about.
Yes?
The method of finding the area, take the just intervals. Is there a way to see, based on the number of intervals you take, how far off it will be from the actual solution?
It's a very good question. So, yes, you can determine the error. Very good question. So, you can determine the error that you make using or approximating 4 subintervals, or with, I don't know, 8 subintervals, etc., instead of finding the limit of as n approaches infinity from I equals 1 through n from delta x f of xi, which is exact, right? So if you use the limit as n approaches infinity from the Riemann sum, this will always be exact. But now, I think your question is, and let me know if I understood that correctly, if I use 4 subintervals, what would be the error, right? From the exact to what I obtained. Is that what you're asking, Haber?
Yes.
Yes. There are formulas in Calc 2 to determine that.
Okay, thanks.
Thank you.
I was wondering if we could do one more average rate problem.
Yes. Any function, any problem that you want to work on. Anything. Just give me one. And or I can choose one. It's up to you.
Oh yeah, I had one. It's the
Yes, I'm ready.
x squared plus x minus 10 from 0 to 20.
Very good. So the average value of this function is 1 over b minus a. So 20 minus 0. I don't need to write minus 0, but I just want you to see where it's coming from. The integral from 0 to 20 from the function dx. What is this? This is this, and this is the function. This basically is the integral symbol. But now we want to find the average value, so we're gonna divide the answer by 20. But this is exactly this. This is the area. This or this are exactly the same. Okay, so this is x squared plus x minus 10. Perfect. So first, let's find the antiderivative. So now this will be already my page 3. Okay, so can anyone give us the antiderivative? So I'm going to continue here with 1 over 20 in front. The antiderivative of, or if you want, antiderivative of x squared plus x minus 10, or just every piece, right? So we have x
to the third over 3,
right,
plus x squared over 2
and minus
is 10x.
Very good, that's it. From 0 to 20. Again, careful, not always when you plug in 0 you get 0. Remember, if you have e to the x, when you plug in 0, that will be 1. So do not disregard, but these are polynomial terms, right, or polynomial. This is a polynomial, so when I plug in 0, and all these will be 0. So I only need to plug in 20. So 1 over 20, 20 to the third, so this is 8 and 3 zeros, plus 20 squared is 400 divided by 2, and minus 20 times 10, which is 200. I should write minus when I plug in 0, but that's 0. Okay, so then 1 over 20. I will find the least common denominator to be 6. Adjustment over 2, adjustment over 3, and adjustment over 6. I could have simplified. It's the same thing. Okay, so 16,000 plus 1,200 and minus 1,200. Oh, look at that. Very nice. So I have 1 over 20 times 1,600 divided by 6. I will simplify a 0. I will simplify a 2. So I get 8,000. And then I'll simplify again by 2. So I get 4,000 divided by 3. So that is the average value of this function on the given interval. So if this is midnight and this is 8 p.m., for example, and I have the function that gives a temperature, I will tell you that the average temperature was this during that interval between 0, time equals 0, time equals 20.
I put that in MyLab Math and it keeps saying it's wrong for some reason.
So let's take a look and see how do they want the answer. Let's look at that. Very good question.
Okay, it's problem 14 and 4.4.
Okay, I'm just getting in there. That's why I want you to be on the same page with me, so you can ask questions, so we can solve everything at once. So you don't have to wait for this. Okay, I'm almost there. Okay. Good. Okay, 4.4. Let me take a look. 4.4. Let me review. Okay. And you said this was problem again?
14.
14. Let's take a look. Type an integer or a simplified fraction. I don't see any mistake. You entered exactly, so you entered it and it said it was wrong?
Mm-hmm.
It doesn't say that here. Did you,
It might just be on my end. I was just curious.
no, I mean, let's take a look. Maybe there is something, so maybe there is something I don't see. So 20 minus 0, yes, the integral from 0 to 20, it is x cubed over 3, it is x squared over 2, it is minus 10x. Let me do this again. So 2 to the third is 8, but I have 3 zeros. So 20 times 20 is 400. 10 times 20 is 200. So when I simplify these two, I didn't even have to do anything, because this is 200 minus 200. This goes away anyway. So let me also do it the other way right here, since these two are the same. So 1 over 20 times 8,000 divided by 3. I simplify to 0. Oh, maybe I have too many zeros? Yes, I have too many zeros. I have too many zeros because I already simplified the 0 with a 0. Sorry, 403. Sorry.
Okay.
You are correct. It is 403. I simplified, but then I still kept it in there. Sorry. My error. It's wise not to do 3 things at once. I was talking to myself, not to you. Okay, perfect. So, did you enter it?
Yeah, that's good. Thank you.
Thank you. My apologies. I simplified a 0. So then when I divide by 2, it's just 800, not 8,000. Very good. So let me take it away from here so I don't confuse anyone. Okay, perfect. Anything else? Other questions? Okay, so let's try to finish up this chapter. 4.4. There are many techniques of integration. We will only look at substitution. There are many techniques of integration. Trigonometric substitutions, integration by parts, etc., etc. But we're going to look at only one, which is section 4.5, and which is substitution. Okay, so what is substitution? Now remember from algebra, at some point in time you learned how to, let's say, solve such an equation. E to 2x minus e to x and minus 2 equals 0. You may say, oh, I know how to factor this, but many students will appreciate the method called substitution. You will say, let y be e to the x, because this equation is quadratic in form. It's not quadratic, but it can be replaced by a quadratic equation. And this I know how to solve. I will write y minus 2y plus 1, and then get y equals 2, y equals negative 1, and then go back and substitute. E to the x equals 2, and e to the x equals negative 1, which has no solutions, but here I have to apply log. So this substitution is basically a method that allows us to simplify something so we can solve it easier. So this was an example of an equation. Solved by substitution. This is the substitution. And it gave me a solution in maybe, if you want, a little bit more steps, but much easier to solve. Okay. In the same way, we're going to use substitution for definite as well as indefinite integrals. Why? Because they are complicated. Do I need a substitution if they're not complicated? No. So for example, for the problem that you asked a minute ago, this does not need a substitution. It's very straightforward. This is x cubed over 3, this is positive x squared over 2, and this is minus 10x. Why would I ever think of a substitution here? No, I will never do that. But there are certain situations in which the definite or the indefinite, or both, integrals are way more difficult to solve. And here's an example, or examples. So if you'd like, we can, please open on page 421, and we'll work on as many as we can and as many as we want, from 1 through 60, to apply substitution. You can say you haven't even explained it. True. I'll explain it for each problem, and you'll understand what it means. I will choose, let me choose the first one, and you will choose the second one. And thereafter, if you'd like. Let's start with 26. 26 on 421 is the integral from t squared t to the third minus 1 to the 7th power dt. So this is what type of integral? Is it definite or indefinite?